Hi there, fantastic 5th grade super sacred scientists. This is Mrs. Neff coming to you today to talk about TEKS Objective 5.6b. Within this objective, we should be able to explain how the flow of electricity in circuits requires a complete path through which an electric current can pass and can produce either light, heat, or sound. We should also be able to differentiate between a series and parallel circuit and determine how to test if a circuit is either series or parallel. We will also learn to trace complex parallel circuits and decide what will happen when switches are either opened or closed and which switches should be open or closed to achieve a desired outcome. Let's start by talking about what is electric energy. Well, electricity is a type of energy that can either build up in one place or flow from one place to another. When electricity just gathers in one place, it is known as static electricity. The word static means something that does not move. We've noticed the buildup of electricity when we've walked across carpet and then touched something that allowed the electricity to flow from one place to another, like a doorknob or another person, and we get that static pop. Or when we rub a balloon on our hair and our hair stands up 6 inches high. But electricity that moves from one place to another intentionally is called current electricity. A circuit is a complete path around which electricity can flow. It must include a source of electricity, like a battery or an outlet. In class, we've been using batteries. Have you ever heard the expression, opposites attract? It is very true with electricity. Electricity flows through a circuit because the negatively charged, what are those called again? Yeah, electrons, are trying to pair up with the positively charged, do you remember this one? Protons. To allow the negatively charged electrons to flow through the conductor, one end of the conductor must be connected to the negative terminal of a battery, and the other must be connected to the opposite positive terminal of the battery. Without a conductor connecting these two terminals, we will never have a closed circuit allowing electricity to flow. When electrons move, they carry electrical energy from one place to another. This is called current electricity, or an electric what? That's right, current. Just like the current in a river, electricity flows. For an electric current to happen, there must be a closed circuit. Look how this word circuit looks similar to the word circle. A circuit is a closed path or a loop around which an electric current flows. A circuit is usually made by linking an energy source and electrical components together with some type of conductor, like wire. Materials such as water, copper, gold, and silver that allow electrons to flow freely are called conductors. That's why we use wire, which is made from ductile metals like copper. Materials that don't allow electricity to pass through them so easily, such as rubber, wood, glass, and plastic, are called, do you remember this? Sure, insulators. If a circuit is broken, it is called what? It's called an open or incomplete circuit. This can happen by opening a switch or removing a component from the circuit. If a circuit is not broken, it is called the opposite of open, which is closed or complete circuit. This is an area where kids get confused sometimes because Open circuits allow no electricity to flow, while closed circuits allow electricity to flow. There are three main types of circuits that we've discussed called simple circuits, series circuits, and parallel circuits. A simple circuit is simply a circuit that has only one component, like a bulb, a buzzer, or a motor, connected with an energy source like a battery and a conductor like a wire. So the series circuits we've looked at, some of them have been simple circuits. A series circuit, though, has more than one component connected in one continuous loop, whereas a parallel circuit has more than one loop or path for the current to flow through. Think of a series circuit being like a charm bracelet or a charm necklace, where one charm is right after the other, all on the same chain. Think of a parallel circuit as being more like a spider web, where you have lots of branches and paths. A simple circuit is built with, like we said, the minimum number of things you have to have a functioning circuit, like a power source, a conductive path, usually wire, and a resistor, which we call a component or a load, like a bulb, motor, buzzer, etc. Some real-world examples of simple circuits are flashlights and doorbells. Lots of things we have in the kitchen, too, and some of the models we've built in science. In a television series, you get several episodes, one right after another. And you can think of a series circuit as being similar. You have several components, one right after the other. If you follow the circuit diagram from the positive terminal through the closed switch, through the light bulb 2, light bulb 3, back to the negative terminal, you have connected one component after the other in one straight path. That's the only difference. Any device that makes you flip two switches before it turns on, like lawnmowers for safety, or shut everything down when something goes wrong, like flipping a power breaker, table lamps, and holiday lights are all real-world examples of series circuits. The most common would be holiday lights. If you put more lights into a series circuit, each light will get dimmer than the light before, until eventually one will probably not come on at all. This is because the resistance is getting greater as you go through. In a series circuit, if a lamp breaks or a component is disconnected, the circuit is broken and all the components will stop working. Here is a diagram of a series circuit. We have the symbol for a battery, the symbol for a switch, and the symbol for a light load. So here we have two lights, and this is a series circuit. So when we close the switch, it allows the electrons to flow freely through each of the light bulb loads back to the positive terminal. So positive to negative, complete circuit. What happens though if we open this switch? Both lights will turn off. What happens if we remove one light bulb? If we remove one light bulb, since there is only one path, we're going to lose power in the other light bulb as well, because we will have an open circuit. See? Now, with a parallel circuit, you have multiple paths. If you look at some of the models here, you go from positive through the component back to the negative. And we have a second path that goes from the positive through this component back to the negative. And a third component has its own unique path. Can you see that? Does it make it a little more clear how this is working? So if you put more lamps into a parallel circuit, the lamps or the light bulbs will stay brighter. In a parallel circuit, if one light breaks or a component is disconnected, there are other paths so the components remain on. Some real-world examples are the wiring in our homes. If it weren't for the parallel circuitry in our homes, when we turned off the light in the bathroom, we would shut the refrigerator down. That wouldn't be so good. We'd have a lot of spoiled food. Another example would be the light bars over the top of the vanity in the bathroom. You notice sometimes they have 4 or 5 light bulbs. If one goes out, we're not completely in the dark. The others stay on until we replace them. Here's a diagram of a parallel circuit. And just like in the previous example, this symbol represents battery. This symbol represents an open switch. This is a light load, and this is a light load. And if you look, we have the ability to leave the positive. If this switch was closed, go through the negative, through this light load, back to the negative, and the same thing through this light load, back to the negative. We close the switch and all 3 lights come on. Trace those paths, and you can see that when we close the switch, the electricity will flow through each of the light bulbs independently. If we remove one light, the other 2 remain on when we close the circuit again. The only part of this circuit that's been broken is this open part right here. We are still allowed to have electricity flowing here and here. We have 2 complete circuits left. So let's review. In comparison, a series circuit has what? That's right, only one path for current to flow. Whereas a parallel circuit has, you got it, multiple paths for current to flow. In a series circuit, we have resistance that is increasing from one to the next, whereas in a parallel circuit, our total resistance stays the same. What's an example of a series circuit? Holiday lights. And an example of parallel circuit?